This video will compare the time it takes to export and get long-term deflection results of a transfer floor using the old RC building and the new RCB. In RC building, the floor will be manually exported and cleaned up in slabs to get the long-term deflection results. RCB will use the new automatic batch export and analysis feature. At the end, the time taken between the two processes will be compared. We are in the preliminary design stage of this job, and we are determining the slab thicknesses. We're also trying to decide if we're going to use an RC slab option or a PT slab. This example will just show the slabs and SLB export to check the reinforced concrete option. So in the real job, the process that will be demonstrated now will be repeated several times. The floor that is to be exported has a relatively simple layout. The model has been cleaned up in RC building and runs without any meshing errors. When exporting to slabs, reactions via static analysis is chosen, as we want to consider the varying distribution of reactions in the walls above. Opening slabs. There are many meshing errors despite the model being clean in RC building. This is due to the fact that point load reactions from the export are causing errors. They all have to be cleaned up for both the dead and live load cases. Fast forwarding the cleaning process. All errors had to be cleaned up and we had to remesh about 5 times. All in all, this took about 10 minutes for this floor. If the floor was more complex or was in the diagonal direction, this could have taken up to half an hour. Again, this would have to be done per export from RC building. This is just one iteration. During the preliminary design stage of this job, this floor had to be exported about 8 times, as various slab thicknesses and framing options were trialed. The other option would be to export reactions with an undistributed load in the wall, a line load, that would not cause meshing errors, but would not capture the true load distribution within the wall. Time-consuming model cleaning or loss of accuracy and guesswork. Neither option is ideal in this case. For comparison, in the new RCB, opening the batch export and analysis form, the level 2 transfer floor is selected and run. The floor is automatically exported to SLB and SLB is run in the background. The mesh calculated in RCB is reused in SLB, so the running is much faster. The process that took 10 minutes in the old software took about 30 seconds in the new software. The results can then be viewed in RCB without having to open any other program. Going back to the batch export form, we can then select all other non-typical floors and batch export and run. And we can also export and run both static analysis and floor area reactions at the same time to compare the various results. Now, we will compare the time spent operating the software using both the old and new method. Note, this does not include designing the slab or viewing results. This is just the time we have spent working with the software to get to the stage where we can view the results. The old software was 10 minutes for this floor. During the preliminary design stage, this floor had to be exported a total of 8 times. 4 RC options and 4 PT options, as various thickness and framing options were checked both in slabs and PT3D. This brings the total time to 80 minutes for this floor. There are a total of 4 non-typical floors in this job, and they also had to be exported a similar number of times. So the total time spent importing, exporting, cleaning and recleaning meshing errors in the old software for this job just during the preliminary design stage was about 5.5 hours. In the new software, this is all fully automated. So the time spent is just the time we wait for the software to run. One run of all floors took about 3 minutes, and 3 minutes times 8 options is about 24 minutes total. So for this job, during the preliminary design stage, 5.5 hours of manual software operation reduced to just 24 minutes. The batch export and analysis greatly reduces the time spent operating the software by fully automating the exporting and analysis procedure. Manual transfer of data between the software is eliminated, and the engineer no longer has to guess long-term deflections based off I gross values calculated by RC Building. Less time can be spent operating the software, and more time spent finding an efficient structural solution.